we're interested in looking at the spread of data. So quartiles allows us to break it up into smaller chunks. Percentiles, well, that's when we divide it into 100 parts. So, in other words, how we usually mark a test, what percent did we get. But the actual percentile tells you what percentage of scores that you were, well, better than, I suppose, is a way of putting it. So if you were in the 90th percentile, then your score indicates that 90% of the scores were less than yours. In other words, you're in the top 10%. But you can break it down to smaller and smaller chunks. Deciles just break it into 10 parts. So break which of the 10 percentage groups that you're in rather than single percentage. And quartiles then divides it into 4 parts and breaks it up into 25% each chunk. So the first quartile is the lowest, 25%. We call that Q1. Well, the quartile is not actually the chunk, it's the limit at the top. So Q1 will be whatever that score is at the top of that 25%. Quartile, it would essentially be the 25th percentile, if you like. Another way you could say it. The second quartile is just another way of saying median, because that would then be where 50% is below. Well, that's what we understand median to be. And then our third quartile would go up to 75%, and then from there we can work out what we call the interquartile range, which is probably more useful than range itself. So it just tells us what the middle 50% covers. And the reason that's more useful than range can be really deceptive, because you might have one outlier which is, way above everyone else, but it doesn't really give you a true measure of the spread then, because it sounds like, all the marks went up to this really high mark. So just capturing the middle 50% can give you a better idea of the spread. So we have our lowest score, which would go up to Q1, so 25% there. Then that goes up to the median, which then goes up to Q3. So that's the interquartile range between those two. And then the last 25% would take us up to whatever the highest score is. So how do we calculate it? Sure, it's Q3 minus Q1. But just like when we worked out median, if we had an odd number of scores versus an even number of scores, how we would handle the data, same sort of thing will happen here. So let's look at this group of numbers. And again, I put them in actual order there. We would get rid of the median for this one, because with an odd number of scores, because that will then give us 2 equal sized groups either side of that middle. Both of them are 4 in this case. And then I would find the median of the first 50%, which in this case average of 2 and 2 is 2, and then the median of the other side, average of 8 and 9 is 8.5. That allows me to work out the interquartile range of 6.5. Now if I've got an even number of scores, then I just simply break it into 2 parts. Then I find the median of the first part, and in this case I've got an odd number of scores, so it is 8. And then on the right hand side, again 11, I've got my interquartile range. The median, of course, for this one we would have to average 9 and 10 together there, which brings up the 5 number summary. So those key pieces of information, which is simply what's the minimum mark, Q1, the median, Q3, and the maximum mark. So they're the 5 pieces of information that make up the 5 number summary. And so for our 2 examples there, we'd have for the first one 1, 2, 5, 8.5 and 10, and the second one 6, 8, 9.5, 11 and 15. Just writing them as a list of numbers though, not that great, which is why we have our box and whisker plots, because we can put it in a graphical format, and it's a lot easier to sort of get a feel for the data when it's drawn as a graph. Here's 2 sets of data. So a major exam for 2 classes. There's the results for class 1 and class 2. And we're going to place them in a parallel, because we want to compare the 2 groups. Parallel box plot. So there's class 1 and here's class 2. It looks like, look at that bottom 25% for class 2. Wow. But that's being affected by these couple of really lower marks, the outliers there. But anyway, that top one, well there it is, that's how we draw one. So the whiskers go out to the lowest score and the highest score, and then the middle part, that interquartile range, is the box. That's what we're really interested in looking at, and then we place where the median is there. So those outliers, the ones that are way out, how do we tell if something is an outlier or not? When is it okay to not include the data? Well, generally something like this. You work out the interquartile range. You go, well, what's 1.5 times that? And if any score is more than 1.5 times the interquartile range, then Okay, I'm going to call that an outlier, that piece of information. If you're reporting on data, if you are going to exclude that from your stats or your average and what have you, you would make a note of that in your report that you're writing about the data. All right, there's those parallel box plots, but now I've put class 2 in two different ways. One where we included the outliers, one where we didn't. And you'll notice when we didn't, it probably gives us a better idea of the comparison of those two groups. It's a lot closer than what it originally looked like. How did it affect it? So class 1 had an average 82.1, standard deviation of 9.37. Now with the outliers, it looks like they've done significantly worse than the other class. So a 10% difference in the average there. But a very large spread, 17.07. If we take those out, the average is still lower, but certainly not by as much as when we included those outliers. It comes back to much closer there, and the spread comes in as well, of course. Okay, there's a bit about, quartiles.